This section covers Java EE concurrency. We are going to take a look at how asynchronous execution can improve the behavior of your Java EE applications, which asynchronous APIs are offered by Java EE, how Java EE multithreading was done without those before that, what Java EE concurrency utilities offer to run your application asynchronously, and we are going to take a look at some of the new asynchronous features that were added in CDI 2.0. In this video, we are going to take a look at options for asynchronous execution. Why asynchronous execution is important, especially in the context of Java EE, what types of asynchronous APIs Java EE has to offer, and take a look at some example code for these APIs. Java EE has a number of APIs to support asynchronous execution. As we heard in the first section, if two modules, for example a sender and a receiver, are both executed in a single thread, then the thread is usually blocked until the second module responds. Now if we take this further into the Java EE platform, for example communication between two servers or between the web tier and a client, like a browser, then the server thread will always block until the server responds back and the UI, for example, would seem frozen or blocked. So this is where asynchronous execution comes into play. For example, if the server thread can be suspended and the actual business logic executed in a separate thread, then performance and the scalability and the user experience can improve quite significantly. Let's take, for example, a listener thread for an HTTP request released immediately, and then the business logic can be executed on a separate thread and respond either via a Java util concurrent future or by using a callback handler registered by the client. And that, of course, makes the application a lot more responsive and appealing to end users. Java EE has always had many asynchronous APIs. The first example would be JMS, which has been around ever since the initial Java EE. With EJB 2.0, the concept of message-driven beans was introduced, which is used quite a lot for asynchronous execution ever since and even until today. Starting with Java EE 6, there were a few other APIs like EJB or Servlet getting asynchronous functionality that also works by using multiple threads. And with Java EE 7, more of those have been added, for example JAX-RS 2, the first version of the WebSocket API, or the concurrency utilities for Java EE 7. And with Java EE 8, CDI 2 has also been further improved for asynchronous behavior. Now let's take a few code examples. Here EJB 3.1 introduced a special asynchronous annotation, and then the Java util concurrent future that we already know from the earlier section gets returned after payment has been processed in an asynchronous way. Servlet 3.0, since version 3 allows to instantiate threads either by creating a new thread or here calling the thread pool. So here in the web listener of a web application, an executor is put into the servlet context, and then when the context is destroyed, the shutdown method of that executor is called to have a clean slate and shutdown of the thread executor. JAX-RS 2.0 also allows to call new threads Here's an example where a new thread is instantiated in the submit method using an async response, which is a new API element of JAX-RS 2.0. And last but not least, in the WebSocket 1.0, you can also call methods like getAsyncRemote and execute methods asynchronously. We left two other APIs out here because we are going to take a look into those in more detail in the following videos.